pencil? Does anybody else need pencil before we start? Carlos. All right. So on page, what did we just say? 148 now.
148.
Yep. We look at that three graphs on page 148. I want you to take just a quick minute and look at those three. And I want you to think about those three here. And I want you to tell me which of those three does not appear to be hiding a line, or does not one appear to be kind of linear? Which one does not appear to be kind of linear? Jayla? Yeah, why would you say B? Because B, it's kind of all scattered about, right? Now, what would you say A is generally doing? Decreasing is going down, right? And what we would say C is generally doing? And I would say you can see a line hiding inside of that one, right? And you can see that line is generally hiding inside of that one, right? But on B, as Jayla said, I don't see a line hiding in this one, right? It does not appear to be linear. So in data, excuse me, in data here, real world data, sometimes data is just not linear. What else do we have besides linear? What other families are out there besides linear? Absolute value, not quite constant, but family. Exponential, quadratic, those are our families, right? So we tend to focus on linear a lot in Algebra 1, but we have some other families. We'll get to those other families more later on. But what we're going to focus on is primarily linear data. A lot of it is going to be linear. So what we're going to look at today is that correlation coefficient. So what does the correlation coefficient tell us? The correlation coefficient tells us is it's a specific number. And depending on what that number is, it tells us how strong something is to say it is linear. Now, Jayla immediately said, I saw Chris and Ann go up too. They immediately said, this does not look linear, right? So what I would say is our R value, our correlation coefficient, the number that goes with this one, it's not going to be a strong R value. So depending on what this number is, it's in relation to how strong we say something is linear. You said A and C definitely looks linear, right? I see something linear hiding inside of here. I see something hiding linear inside of here. So this is going to have what we say is a strong R value than this dude, okay? Now, let's do some writing here, okay? What did we just say this is going? This is a negative, let's use the, yes, decreasing, absolutely. We're going to actually say this is a negative, whoops, let me write a little bit better. A negative correlation. Now, we got some labels here, don't we? Let's think about this. What do we have? The weight of the vehicle and the miles per gallon. What usually happens here with the weight of the vehicle and the miles per gallon of the vehicle? The heavier the vehicle gets, the more slower it gets, or the lighter the vehicle gets, the better gas mileage it gets, right? So as the weight of the vehicle increases, the MPG, the miles per gallon, decreases, right? That's where that negative you guys told me was happening. The MPG decreases, the miles per gallon.
Right, so as the weight of the vehicle.
So is that weight, so as you read this, right?
Yeah.
As that weight increases, what's happening to that MPG? It's going down, right?
Oh wait, why would it start?
So here's the weight of the vehicle. So is this weight of the vehicle, this is a light vehicle right here. Right up here, that's a light vehicle.
Oh, that's the one.
And that's the heavier the vehicle gets, it's decreasing, okay? Yep, just gotta take a second to think about that. Now, on the other one that we...
Wait, I have a question.
Yes.
What's MPG?
Miles per gallon.
Oh, okay.
Miles per gallon, yep. So, lighter the vehicle, definitely you usually get the better gas mileage, okay? For those of you that are in drivers, or about to be in drivers, or your parents talked about filling up the gas tank, there we go, okay? Now let's go look at the other one, letter C. What does my axis say on letter C? Time spent studying and grade on the tests. Generally, what happens there?
Is a percentage?
Well,
No.
usually what happens if you spend more time studying, usually
Positive.
you start to see a better grade. Typically. Does it always happen? No. But generally, we see a positive correlation with that. Okay? And that's why your eyes are going up there. We say a positive correlation. So one more time. As time spent studying increases, the what? Grades increase, right? Now there might be obviously some exceptions to that rule, but usually that's typically what happens. Now, got you.
On this one, why you say, wait, no, how much you think the question? How much you think the question? Go do it.
So we're gonna go back to the letter B now. So what's the other one saying? Where Jayla said there is no correlation here, it's not linear. So what's the axis say on the last one there? Your IQ score. So what's the IQ score? IQ score is
Intelligence.
it's something like intelligence. It's not quite intelligence, but that's what the IQ score is. Okay, your IQ score and your height. Is there any relationship between IQ score and height?
No, not really.
If you are tall, you have a higher IQ score. Or if you get a high IQ score, are you tall? No. There is no relationship between your IQ score and somebody's height. So that's where you're seeing this no relationship whatsoever. So we say that there is, again, no correlation. There's no correlation there between somebody's height and somebody's IQ score. That just doesn't make any sense whatsoever right there. Okay? So in those, hiding today is what we're going to start talking about is what we call this again R value. This correlation coefficient that we're going to see now onto the next page. Okay? So the R value, this correlation coefficient is the strength of a data set in determining if something is linear. Is a linear going to be a good model to use here? And if it's not a good number to use, maybe there's a different family to use. As you guys said a second ago, there's other families out there. Absolute value, exponential, quadratic, there's other models we can use. Okay? So what we're going to do here today is start looking at this R value. So you guys are, say, back, when did that start? 2020 was when COVID started. Okay, and when we started, I said when scientists started getting all that data in for COVID, we were talking about, breaking that curve. Okay, breaking that curve because that data was doing an exponential increase. So we were trying to break that curve when the hospitals were getting slammed with patients. Okay, so we wanted to break that curve as the hospitals were getting slammed. So in that regard, they were not using a linear model. What were they using? They were using a exponential model. So in that regard, the R value was saying, hey, linear model was not good to model COVID at that time. Because an exponential model is what was going on. There was a curve in that. So the R value determines, hey, is it better to use, is a linear model good to use or not? If it's not, we use a triangular model then. So on the next page, let's look at the next page. Okay?
Wait, I have a question.
Yes, now.
Okay, so on A, you know how it decreases,
Uh-huh.
and on B it increases.
So
So
on which
why-
one? Which one increases?
Increases?
On B it does?
I mean C, my bad.
Oh, okay.
C.
No problem.
Okay. For those two linear ones.
Uh-huh.
So on A, it's decreasing. Why would you say it was increasing on the FPG? Wait, no, wait. You just said it increases and decreases.
Because as we look at this one as the vehicle, so we're reading this from left to right. We always read left to right, right?
Mm-hmm.
So as this is starting at 0, right? Here's our origin, okay? So as this weight of the vehicle increases, what's happening to this miles per gallon? Is miles per gallon is decreasing, right? So our eyes, we're starting up here at this first data point. This is the weight of the vehicle. It's a light vehicle right here. We get nice gas mileage. But as that weight of the vehicle starts to increase, what's happening to the gas mileage? The miles per gallon is starting to decrease then. Okay? On this one, if we did not spend a lot of time studying, we spend 0 minutes studying, where's our grade at? It's low, isn't it? But as that time spent studying, the minutes go up, what's happening to our grade? It starts to increase then, okay? So we always start kind of here from left to right, just see where that data starts off at, and then follow your eyes, okay? So let's look at the next page, all right? So this is what I just kind of talked about, this correlation coefficient. Now, here's where it gets a little tricky. We were talking about this in our Algebra 1 meeting with the other teachers yesterday. We've already seen about the decimals and rounding. What have we seen about some of you guys' rounding skills? Especially you guys. Our rounding skills are what? A little weak. Yeah, a little weak. So what we're going to do here today is we're going to throw in a little bit of curveball now as well. We're not going to round, but we are going to talk about a number line here and throw in some negatives with it. Because what does the correlation coefficient is on a number line. So here's what we got. We got this number line. I would draw this off to the side as well. This correlation coefficient goes from -1. Actually, let me do this. We go from -1 to 1. And 0 is right there in the middle. Okay? So the correlation coefficient, it is on a slider from left to right, from -1 to 1. 0 is in the middle. Now, when I kept saying if it's a strong linear model or not, look for example. Okay? To be strong, you got to be close to either 1 or -1. So if you're a 1, when we run our program and that R value returns like a 1, we say we have a strong positive linear association. Okay? So what that tells me is our data is looking pretty darn positive, increasing. It's linear looking. It's going up nice and neat. Okay, and we're going to do all this practice, but we got to kind of get out the vocabulary to start off with. If you ran your program and the R value is closer actually to -1, well, what do you think about with negatives? What are your eyes doing usually? Going down. So what we then say is, over here on the other side, you have a strong, not positive, but strong negative linear association. Okay? So your R value is going to fall somewhere between -1 and 1. Somewhere in between there. And then the last part where it can sometimes land in between, or not in between, but if it's closer to that 0, 0 is where we say it's weak. What do I mean by weak? Jayla pointed it out a few minutes ago. Which one was not linear on the previous page? A, B, or C? B was what we say was no correlation, no linear correlation. That was what we say is we call a weak linear association. Okay? So you guys have not paid attention to anything to those R values yet. So you've ignored them. Now we're gonna start paying attention to those numbers. And those numbers are gonna start falling someplace in our number line. And where they fall tells us what type of linear association we do. Now every year I've done these with the students. The first day, second day is usually a bit of a, I don't know, it's okay. But usually kind of give me some time, all right? Now usually what the graph looks like, let's draw a picture of the graph below. And we're gonna do some work on Monday. It's Friday, but we're gonna do some work on Monday. So what do I mean by a strong positive linear association? Your graph is gonna look like this. Okay, you're gonna have a lot of dots, a lot of points that are making a positive, they're all in the line. That's exactly what it's gonna look like. Does that look linear? Sure does. It's gonna be positive, it's gonna be increasing. What's gonna look like for a negative one? It's gonna be decreasing, and they're all gonna be on a nice line like that. Okay. Now, what's it gonna be like when the R value returns me a 0? We just said a second ago, letter B on the other side was a 0. What that means is your eyes are all over the place. You can't tell me it's linear or not. So what does that mean? Can you tell me anything linear is right there? No.
Well,
That is what we say is a weak linear association. I can't determine anything that is linear inside of that. That is what we mean is a weak linear association. Now we get the last one here I'm going to throw in there, and then we're going to do some practice with it. Okay? Let's do some in between there. What do I mean by in between? What's in between 0 and 1? 0.5. So think about it. What's a 0.5? 0.5 is like a medium. So what's a medium between this hot mess and this nice clean one? It's kind of almost what you saw on that previous page, but a little bit more spread out. What it means is you've got something a little bit more spread out, but generally what is happening here? You can still see it's going what? Up, increasing, and can you at least see that there is a line hiding inside of there? That's a 0.5 R value. That's usually what happens with the 0.5. Now go make me a negative 0.5. What's a negative 0.5 going to look like? Yeah, it's going to be decreasing and look exactly like that, but decreasing. You're going to kind of merge those two together. Again, it's going to be kind of spread out still. But generally, what's going to be happening? It's decreasing. And again, can't you kind of see that there is a line hiding someplace in between there? And it's going to kind of a merging of those two. So that's what we're looking at here the next few days is R values. All right? All right, let's keep this in mind. This is your buddy. This is your buddy here. Later on, I'll put that on the board. That'll be kind of our guide over the next few days until we get comfortable with this. Okay? So keep this as your guide. You got a multiple choice here. All right? This first one, we're looking about using our correlation coefficient, our R values. So in that first one, which R value you think is matching with letter A right here? Now, let's play that process elimination. What are your eyes doing on this scatter plot? It's decreasing, so which ones are you going to cross off? The first, second, third, fourth, which ones are you going to scratch out? First and third, because those are positives. Be smart. Do those test-taking skills. Okay? So those other ones are increasing, so that ain't going to happen. And we can clearly see that those are negative. Cool. Great. Sounds good, Jayla. Now, on the two that remain, they are negative. But now we're going to go look at our scale here. Does this look pretty darn linear, or is it all scattered about?
Linear.
It looks pretty darn linear. So which one is closer to, whoops, this is negative. Which one is closer to -1?
0.9.
Thank you. Okay? The closer you are to looking linear, that means the closer you are to -1. It gets a little bit straighter. That's correct. And the closer you are to 0, you're all over the place. Correct. And -0.9 is closer to -1. So what we say then is, on this one, we say this one has a strong negative linear association. That is absolutely correct. So what we would do then is, if we're working in a lab, we're working in accounting or something like that, and we're running our program, we would say we're going to use a linear model at this point. Okay, that's one down. All right, how about letter B? First thing I'm always doing is eliminating my options. Read that thing from left to right. What's your eyes generally doing? Our eyes are generally increasing. Can you scratch out any possibilities? Ryan?
You said any possibility?
Which ones can I possibly scratch out?
0.07 and negative 0.07.
I can cross out those negatives, right? So generally we're increasing. I'm going to scratch out those negatives like you suggested. Scratch those out. Make your life easier. Now, of the two that remain, one is kind of closer to 1, and this one is kind of what? Closer to 0, isn't it?
The first one.
So the one that is closer to 0, again, boo, that's way all over the place. I can't make anything out of it. And the one that's closer to 1, 0.7 is like right in between this. And that looks like that's more in between, isn't it? So as Ryan suggested, I also heard from Jayla, that appears to be this matching one right here, a 0.7. Because I can clearly see a line hiding inside of there. So what we would say then is, this has got a strong linear, and I forgot to say what? Positive. Strong positive. Try this again. Positive, because it's increasing, linear association. You get that going? You guys are on the right track for today. That's half the battle. Figuring out what this R value is, calculating, it's easy. We've been doing that. We just turned it on your calculator. All right, last one there, letter C. Letter C, as you read that thing from left to right, what are your eyes doing on letter C? They're scattered. So when I see that scattered, that's hard to determine. Okay, so let's look at the options they give us. Because my eyes are bouncing all over the place. So when I look at my options here, what does a 1 tell me? A 1 on my number line is perfect. A 1 is absolutely positive. Everything is nice in a row. It's making a line. That is sure as heck not what I have, is it? We just did a 0.5. A 0.5 is not nice and neat, but generally what should a 0.5 do? You can still see the line, but that's not what I have. And then finish it off, Ryan. What should I have?
The last one.
The last one. Because 0.01, use your number lines going back to decimals. When did you guys start learning about 0.01 and decimals on number line? Way back when. And 0.01 is super darn close, like right up on 0. And this is what we say we have a weak, barely see line. I don't even know if the line exists. The line doesn't exist, actually. We say this is a weak linear association. So what this tells me, if I'm, like I said, I'm the scientist running in the lab, or I'm the accountant running my software program for finances, I'm not using a linear model. I'm going to look to use maybe an exponential model. Okay, that would be something better to work here, something completely different. Yeah, okay. Now I think we're actually gonna use our calculators. Okay, we're gonna use our. Actually, we're not. We're gonna use our hands here to use this. Gosh, Marianne, if you're like, oh my God, this is disgusting. No, we're not gonna use our calculators. Can do this for us. This is what our calculators are doing behind the scenes. Okay, so let's go plug this into our calculator. Make sure it is turned on. So everybody go to your calculators, bring up Desmos for me on your Chromebooks. If you get Desmos enabled, let's get that R value. R values are going to typically, we're going to round those to 1,000, okay? Even though the R values, I think in our book just now, we're going to 1 decimal, 2 decimals maybe. I know on the quiz and test, we usually have 3 decimals, 3,000. So let's go plug that into your calculators, everybody. Let's go run that linear regression program. So remember, this is written as that in our calculators. So let's go plug them on in. All right, so I'm going to do that same thing. So this is crapped out. I got to run again. Give me a second to enable that. I like my other program. Okay, so let's again make sure that, again, you're going to find out very quickly that if you've turned it on or not, because the R value should again be enabled. So go to stat, enter, and go type in 23, 1, and 3. Go to L2, and what do we got? 23, 2, and 4. Okay? Stat, calculate, and we are always still living in option 4. Go calculate. Desmos people, you're doing the exact same thing. Now, if you've correctly done this, you enabled the stat diagnostic is what we needed for you. You should now have that screen that you've seen a couple times on the reviews, on the quizzes, enabled on your calculator. If you do not have that screen on your calculator, you better raise your hand right now. Okay? If you do not have that, you better tell me. Now, Desmos people. Oh, yeah, sorry. That's just for 84s. Desmos people, you are doing nothing different. You're just typing it on in as is, because on Desmos automatically puts that in there, and we've been ignoring it. It's been at the top of there. Now we're not going to ignore it. So you got to go run your program exactly as is. Y1 squiggle A what? X1.
It won't let me do it.
Give me a second. Plus B. Okay, there's my Desmos people. Okay, there's my Desmos people, and then where's my 84? All right, let's talk about this. Okay. See what we got.
Everybody
All right.
It's really better now.
Now, let's take a look here. My R value for Desmos people is right here. One more time. You're always going to take your finger, if it's on a worksheet or something, you're going to scratch out the R squared. We have not said the word R squared besides to ignore it. You're going to look at the R value, R equals. Now, Desmos, R equals 1, and my 84s, they aren't saying the same thing, are they? Okay, for the R value. My R value on here says 0.99999, and on Desmos, I think they're saying 1, isn't it?
Yes.
Okay, so no big deal. What that means is Desmos is just going ahead and rounding that up. So whatever your calculator says, you're going to have to go with that. So for Desmos people, your R value is what? R value is 1. And for 84s, when I said you round it to nearest, what, thousandth? Well, what's going to happen when you round it to nearest thousandth? 1, 2, 3. Behind the 9 is a 9. That's going to round up to 10 and 10 and 10, which gives me eventually to 1. So the R value actually turns out to be 1. And what does a 1 look like? What does a 1 look like from our previous page?
Linear.
It is very much linear, right? So we say that this has a strong what? Linear, strong what? Positive or negative? Positive, because it's a positive 1. Just like that slope tells me it's positive, the R value tells me it's also positive. Absolutely. That's what we want to hear. Okay? Okay, let's do one more here. Let's go to this page. All right, I want you to run that program. Let's run it again. Let's plug in that data. And I want you this time, and this time I don't think it gives you a 1. So let's type that into your calculators, guys. Go run me that program all over again. As you do that, I'll do the same. Excuse me. Just edit, clear it out. L1, always hit clear, never hit delete. Okay. So 1400, and as you're typing that in, whatever you're doing, please make sure you're typing that in correctly with these little bit larger numbers, and making sure your technology is getting all those zeros, and you typed in 2600 instead of 260, because I could see easily you not typing in everything correctly. All right. Yesterday, somebody was working on Delta Math in my 6th hour. They said they typed in everything correctly. When I looked at their calculator, they did not. They typed in like 5 on the left and 6 on the right, so it wasn't matching up 1 to 1 there. So always make sure you do a double check and you typed in your data
When we're
correctly.
doing ours, we're going to the thousands.
Thousands, correct. Yep. So, as you do that, run your program, calculate it. Does most people? Again, everybody's in the same boat. We've done this.
Mine look weird.
That's okay. No, what do you say? Looks weird, though. Okay, so see how this says X1, X2. When we did that one, you gotta make sure you have everything X and close it out.
Oh.
So make sure you get the X's on those and start crushing it. Now I think we should as well. All right, that's most people and 84 people. This is what we should be getting. Jayla, did you get the same numbers then that I have up here? Andrew, get the same numbers as I got, hopefully.
No.
We get the same numbers. Check me as well.
455, 545, 750, 30. Oh, I put 100. There we go. There you go.
Andrew, did you get the same numbers?
I just had to fix them.
You get the same
Is it your
numbers?
table?
Yes.
I don't know either. Oh, this is a 450 right here. Okay, now you're good. That's a 450. Okay, we're good. All right, I think you're good now. Let's go ahead and let's bring that together now. Okay, right here. All right, let's go to the next page actually. All right.
Do we need to answer the question?
We're gonna come back to that in a second. Let's write the regression equation. Now, when we write the regression equation, that is what we've been doing. AX plus B. So here's the mistakes that we usually see. Make sure you're using A and B.
So wait, is I gonna be basically the slope?
Nope, the R is not the slope. The R will be X in this next one, okay? So when you look at the regression equation, AX plus B, the slope is A, 3 decimals. What is that? 0.282 X, right? And what is the y-intercept? The B. That is the B, the y-intercept. 36 point what? 273. 273. Okay? Now, right here, when we say the word correlation coefficient, that is what we mean by the R value. Okay? So what is the R value here? If you could scratch out R squared, scratch it out, but ignore it. 3 decimals, 0.982. We're going 3 decimals, people. Okay? 3 decimals, 0.982. That is absolutely correct. So with that now, all right, we're going to go back now and make that scatter plot, and we'll answer that last question. Okay, on that scatter plot, plot those points. If you haven't done so yet, let's plot those points, and then we'll finish this off. Okay, 1400. Go find 1400 now. Oof, the scale is a little odd. Okay, as I look at this scale, I got 400, and there's a bless you. Wow. Okay, got 400 here. I got to mark the 400. This is going by twos, by 200. So 200, 400, 600, 800, 1000, 1200. So this is going by 200s down here. So 1400 here, and then above it's going by 50s. So 0, 50, 100. So got to watch that scale, unfortunately. 1400, 300, 350, 400, and 450. It's going to take us a minute to slowly graph those. So this is going by 50s. This is going by 200s. It's an annoying scale. 1550. You're going to have to eyeball it. It's going to be close to the other one. 505. Again, it's not going to be perfect. 2000. Right there. 545. Come on. 2600. 715. 3,930. 3,930. And what's the last one? 34. And 1,000. Which is up at the tippy top. I'll pause, give everybody a chance to make sure you're at the same with us, and then we'll finish this off. Okay. Pause. This is our last one, guys. It's been a long day. I know, JL. You'll live. You're almost done with me, JL. You get a couple days off from me. Okay. So we plotted that. We got our scatter plot. Now, on that scatter plot, does that kind of work hand in hand with our R value? Our R value, we said, was a 0.0982. You are correct. 982. And what are our eyes doing here? Do you see a positive, almost line hiding there? Yeah, I see that. So those two things work hand in hand to answer that last question Andrew said we skipped over. So let's go answer that last question. The scatter plot with our R value, they work together to say, yep. We're going to say a line of best fit, a linear equation would work because 2 reasons. Because the scatter plot appears mostly linear. That works together with the R value. The correlation coefficient is a strong, positive, linear R value. I will pause and shut up now for 30 seconds for you. Unfortunately, reached a part of the notes here where we got a little bit more talk to do with the correlation coefficient there. Those two things have to work together. Okay,
No, no.
that's okay. I'm just going to finish up talking here. So, with today then, it was a rough, that was